All right, welcome back. We're at section 13.2 right now, and in 13.2 we're going to be talking about radian measures in degrees. Now, some of you have seen radian, the word radian before, because when you're doing trigonometry, you always have to change your mode from degrees to radians. So it might make a little sense to you. Let's take a moment here and take a look at what the whole concept means. We're going to look at this unit circle here. And in the unit circle that I've copied for you, you'll see all the way around the circle is 2 pi. So what this is a guy, how I like to think about it, who's traveling. Maybe he's running. Maybe he's got a hat on. He's traveling all the way around the circle. So when we talk about degrees, we're talking about angle measures. You know, if you went 30 degrees or 45 degrees or whatever. When we're talking about radians, we're talking about the distance walking around the circle. If I took a tape measure and I put it all the way on the circle, all the way around and around and around, we're talking about radian measure there. So, what's the circumference of a circle? 2 pi r. We all know that. We learned that when we were younger, right? 2 pi r is the circumference of a circle. Well, if this is the unit circle, or the 1 unit circle, that means the distance from here to here is 1 unit. So the distance all the way around the circle is just 2 pi. Halfway around the circle then would be pi, and so on and so forth. So that's what radians will be. That's what we'll be studying here. Let's get that up out of the way a little bit. A couple of things. Initial side and terminal side. When we talk about forming an angle, you have the initial side, and then you rotate that angle to the terminal side. That's how you get initial and terminal side. Initial, terminal. Standard position is the position of an angle whose vertex is at the origin and its side lies on the x-axis. When we talk about standard position, we're really talking about things that are over here in quadrant 1. If that's quadrant 1, 2, 3, 4. Standard position is anything that looks like it starts in quadrant 1, even if it's all the way over here at 130 degrees, at least it was in quadrant 1, so that's standard position. Coterminal means angles in standard position whose terminal sides coincide. Just means that they are they're related, and we'll talk about that in just a minute. Radian measures, I talked about that earlier. That's kind of the distance around something. Sector is when we take like just this little piece right here, and that's called a sector of a circle. And the central angle is the angle formed by 2 radii of the circle. So anytime you look at the circle and you got a radii and a radii, or a radius and a radius, that's a central angle. It means it's in the center of the circle. All right. Angles in standard position. In a coordinate plane, an angle can be formed by fixing one ray called the initial side. The initial side. Maybe we should make this bigger. Easier to write this way. Initial side. And rotating the other ray called the terminal side. And that's what we talked about earlier. About the vertex. Okay. An angle is in standard position if its vertex is at the origin and its initial side lies on the positive x-axis. So basically here to here. Alright, so if I'm asked to draw an angle with the given measure, like 405, well, if I take this thing at 405 and say, oh, what's that? If I do a 360 degree slam dunk, I'm back to here. So 360 plus 45 brings me right to there. So there's 405 degrees. All right? So we have 45 degrees. The terminal side makes one whole revolution counterclockwise. Counterclockwise. And 45 degrees more. All right? And if I'm going to do negative 65, I'm going to go clockwise this time, 65 degrees. 65 degrees clockwise. That's going to get me down here, 65 degrees. You'll be asked to do that in your homework. All right, find coterminal angles. Find one positive angle and one negative angle that's coterminal. This is in your homework, coterminal. When they ask you to find coterminal, you're just going to add 360 because 210 degrees is over here. How do I get back there? Add 360 gets me back there. How do I also get back there? Subtract 360 gets me back to the same spot. So we have 570 and we have negative 150, and this, by the way, was red, wrong. 210 is down here, not up there, because 180 is right here. Here's 180. 30 past 180 would get you to 210. All right, you guys go ahead and do those checkpoints there. All right, welcome back. Hopefully, when you had to find 485, you were able to do that by doing 360 plus 90 plus 35 more. Somewhere right around there. And negative 75 was right down here. 75 negative. All right. Okay, converting between degrees and radians and degrees. Really simple formula here that you have to know. If you have something in degree mode, because remember that circle, and remember 2 pi was over here, and pi was over here. Pi was over here. Well, look at where 180 is, over here. Okay, so pi and 180 are in the same position. So we're either going to multiply something by pi over 180 or 180 over pi. Well, Mr. Emeott, aren't those the same thing? So then they mean the same thing. So you're dividing the same number by the same number. In sorta that, and that makes kind of good sense that these both would kind of equal 1. So you're not really changing the value of something. You're just changing what it looks like. So if I'm going to convert 315 into radians, I'm going to multiply it by pi over 180. And when I multiply it by pi over 180 and I reduce the fraction, I get 7 pi over 4. Pi over 6, if I want to make that into degrees, then I multiply by 180 over pi. So if I multiply that by 180 over pi, and I'll kind of do the work for you a little bit just so you can see it. If it's pi over 6 times 180 over pi, well, look what happens to the pi's. They eliminate. And it becomes 180 divided by 6. Well, 180 divided by 6, that's 3. Oh, I mean, it's 30. Ha! You go ahead and convert the next two. Pause it and do those. All right. Hopefully, when you paused it and you did these, you just multiplied 200 times pi over 180. And we always keep these in fractions. And we keep them in terms of pi, so it's 10 pi over 9. And you multiplied this one here by 180 over pi. And the pi's cancel out, and you ended up with 36 degrees. Okay. Now, arc length and area of a sector. What's the area of a circle? Area of a circle equals pi r squared. Well, pi is halfway around the circle. That's important to remember. And circumference, we said, was 2 pi r, and 2 pi was all the way around the circle. So when I'm trying to find just part way around the circle, not the whole thing, just this little sector around the circle, when I'm finding arc length, I'm just going to take the radius times how far you want to go. If you want to go all the way around the circle, that's 2 pi r. But if you just want to go partially around the circle, it's r times pi. R times theta, and theta is always measured in radians, so you know. And area, same thing. Pi r squared, well, r squared, and then you have half of your distance. If you're going all the way around the circle, that would be half of 2 pi r squared. What happens to the half and the 2? And it becomes pi r squared. Okay? Okay, so if I want to find the arc length, an area of a sector with a radius of 15 inches and a central angle of 60, the first thing I have to do is take my central angle and turn it into radians. So I'm going to multiply it by pi over 180, and I'm going to get pi over 3 radians. So if I'm finding the arc length of this thing, the arc length, remember that was 2 pi r, so we're just taking the radius, 15 inches, and multiplying it by pi over 3. If I multiply, I get 5 pi. That's a nice answer, 5 pi. I really like that answer. If you turn it into 15.71 inches, that'd be fine too. I guess if you told your local construction guy that the arch over your door was going to be 5 pi, he wouldn't know what was going on. So maybe you need to tell him a little bit more specific, 15.71 inches. And then if you look at the area, we have 1/2 times 15 times pi over 3. And that's going to give you a 37.5 pi, or 117.81. Okay? You go ahead and try that one right there. Alright? Hopefully you ended up with 25 pi over 12 for the, that's in feet, for the arc length, and 125 pi over 24 feet squared for the area. Okay, that's 13-2.